So today we start a new chapter on geometry. And geometry is built off of some very basic building blocks, or what I'll just refer to as the foundations of geometry. And that's really, I'm referring to that informally, but there are some very basic shapes or figures in which everything that geometry is built off of. So I like using a coordinate plane to introduce these basic pieces, these foundations of geometry. And because, well, if for no other reason, we have the space to do so. So I'm going to make use of all four quadrants here and just kind of graduate from one shape to another, to another, to another, just building one shape as we go into another. So the first thing I'd like to do is in our coordinate plane, in the first quadrant, I would like us to plot a point that should be, if you do it in the same location that I'm doing, should be located at the ordered pair 2, 3. Now I know it's 2, 3 because from the origin, I've moved 2 to the right, and then I've moved up 3 locations from 3 steps up from there. So that is an ordered pair. If I wanted to identify it, I could identify it accordingly. We already said it's 2, 3. But what that really represents is an exact location, and that exact location is an example of a point. So I want you to draw an arrow to that and write the word point, and I want you to define that as an exact location. Whoops, an exact location. And I'll even say in space. Now again, most of the time we will identify a point by way of a coordinate, by way of an ordered pair. I'm actually not going to do that in this case because most everything else in geometry is identified by variables. So we're just going to give this point a name and we're going to call it A. So specifically, the name of that point is A. Now I could plot another point and I could give it a different name for variable like B or C or whatever, okay? So just to be clear though, an exact location that we've grown used to in a coordinate plane identifying as an ordered pair, that is called a point, and we should know that. It's not a dot. The name formally in geometry is called a point and is generally identified with a variable. Okay, so from there what I'd like to do is to move into the second quadrant. And again, this is only because we have the space to do so. And I would like us to plot 2 points. So I want you to plot 1 point, and it doesn't really matter where you plot, okay? So I'm plotting 1, and I'm plotting a second point, okay? And as long as you have 2 points, that's all I care that you've done, because we're not going to label these as coordinates. We're going to label them with variables. So let's label one of your points A and label the other point B. And what I would like us to do this time is to connect these points with a straight path. So use a ruler if you can, okay? Mine's drawn freehand, so I know it's going to be a little wobbly because I don't have the luxury of being able to use a ruler. But I want you to draw an arrow to that and label it as a line segment. Now, a line segment, if you think about it, it is a straight path connecting. What are we connecting here? Well, we're connecting 2 points. And those are called the endpoints. So if I want to draw an arrow to A, I can call that an endpoint. Likewise, I can draw an arrow to B and call that an endpoint. So those are my endpoints, okay? Maybe I'll change the colors so we're not confused over it. So one endpoint is A, the other endpoint is B. The other endpoint is B. So now we have a way of identifying specifically this line segment, and this line segment is going to be represented by the endpoints. So the way we name this is A B, and we draw this symbol over it. That tells me it's a line segment, okay? The other way that we can do this, and this is not always the case in geometry, but the other way that we can identify this is in reverse order. Since this is a straight path connecting the points A, B, I can call it segment. That's what this symbol stands for, AB. Or if I work in the opposite direction, I can call it segment BA. So that's really important to understand as well. When we take 2 points, we connect them with a straight path, but let those points act as end points. Then we call that a line segment with the appropriate symbol, calling it, in this case, either AB, or line segment AB, or line segment BA, based on the endpoints that represent it. So if we move on from there, I guess the next logical thing to do is to draw 2 points again. And again, it doesn't matter where you draw your 2 points. So I'm going to put 1 there. And I'm going to put 1 down here. And once again, I'm going to label one of my points A. I'm going to label the other point B. And what I'm going to do this time is start at A, and I'm going to draw a straight path, but I'm going to actually pass through B. So notice I have only one endpoint, okay? So that endpoint, I'm going to put that in quotes, is actually referred to as a vertex. And we should know what a vertex is. We will actually hear that more, but a vertex oftentimes we see as kind of the turning point of an angle or the corner of a shape like a triangle or a square or whatever, okay? But again, this figure here is identified by 2 points. We started with the point A, we have another point B, and this is called a ray, okay? So this is an example of a ray. This is a straight path. And notice what it does. It starts at a vertex. In this case, remember our vertex is the starting point A, and passes through. It doesn't stop at, it passes through a second point. So the way we refer to that, and this is really important because the way that we identify a ray, it's not like a line segment where we can identify it in either of 2 directions. We always identify a ray by its vertex, by its starting point. So we always label it as A, and then it passes through B. And we use this symbol right here. It kind of gives us a visual of what the ray looks like. It has an end point that's kind of invisible to us, but it goes infinitely in the other direction. So this vertex, if we ever see the name of this, we read this as ray. That's what that symbol means, AB. And it makes it very clear to us that we start at A and we pass infinitely through B. This is not going to ever be called ray BA because you notice B is not the starting point, B is not the vertex. So we don't have the same freedom or the same luxury to name this ray in either order in the same way that we named our line segment. So the last thing we should look at is, again, starting with 2 more points. So we notice we did an example of a point in quadrant 1. We graduated up to a line segment in quadrant 2. Quadrant 3, we've used that space to draw a ray. Quadrant 4, we're going to start with 2 points one more time. And I'm just going to make them horizontal. It doesn't really matter. Okay. And this time, I'm actually going to draw through the 2 points. So let's label it A and B. And I'm going to draw a straight path that doesn't start at one of the points and pass through both. It actually passes through both points, okay? So this is a line. So a line is an infinite path passing through two points, and this is really important, in both directions. All right, so whereas a ray only runs infinitely in one direction, a line passes infinitely or runs infinitely in both directions, and both of those are different than a line segment that has two clearly defined endpoints, okay? So here we don't use the terminology of an endpoint or a ray. These 2 points happen to be on the line, and the way that we identify that, there's 2 ways we can name it. Because the 2 points on the line are AB, we can say AB with that line symbol, or just like the line segment, we can flip the order BA. So it's really important for you to understand which of these we're allowed to flip the order. A segment, we can flip the order because it doesn't matter where we say we start and where we say we end. So we can call back up here in quadrant 2, we can call the segment AB because we start at A and then at B, or we can go in reverse order, segment BA, where we start at B and end at A. Likewise, because a line goes on infinitely, we just need to be able to identify it with a name. So we need 2 points to identify that line. And that line can be identified as either line AB, if I read the points that are labeled left to right, or in reverse order, I can label it as line BA. Okay? So those are the key things to remember between a point, an exact location in space, a ray, which is a line segment, I'm sorry, not array, a line segment, which is a straight path. I know we lost some of my writing here, but it's a straight path connecting 2 points. We can name either way. A ray, which now takes on the starting point as being called the vertex, and it passes infinitely through another point. And this is really important. We can only name it one in one direction from the vertex through the second point. And then our line, which runs infinitely in both directions and can be labeled either way. So the last thing we will quickly do, and I know this video is running a little bit long, the last thing we will do is identify what a plane is. A plane is a flat two-dimensional surface running infinitely, and we should know that infinite means forever, in all directions. Whoops, not directs, in all directions. So generally what we will do is we will draw a series of lines like this. These lines are meant to look like they're parallel, and draw lines that also appear to be parallel that intersect. And the really important thing here is that we have to have a minimum of 3 points. So I need to have a point, we'll call it A, a point we'll call B, a point we'll call C, because we need to go from everything up above, which was one-dimensional. That's really important to know. Everything up above was considered a one-dimensional shape, to being able to go into a two-dimensional shape. So we would call this, the way we name this, there's no symbol for it. We call it plane using the word. And we use the minimum of 3 points that are on that plane to identify this. So this would be called plane A, B, C. So it's really important for us to know that whereas if we are dealing with a line segment, a ray, or a line, we need 2 points to give it a name. to give any of those a name. Once we get into a plane, we need a minimum of 3 points because we're basically getting into the idea of creating a second dimension. So make sure you have all of this information filled out. This is going to be something that we refer back to a lot because these are the building blocks of everything about geometry. And then I want you to go on to Google Classroom and answer the questions that you see on the Google form that go along with this lesson. And we'll investigate this more in class tomorrow.